So I want to go fly a kite, and I want to use trigonometry to find out how high that kite is. Now, as I told you guys in class, I'm a very visual person, so the first thing that I'm going to need to do in this case is I need to draw a picture. So let's go ahead and draw a right triangle. If you want to be more creative with it and actually draw in, there's you. Oops, your arms are a little messed up. But there's you flying this really awesome kite up there. You can be more creative if you want to. Honestly, the more details you add, it might actually make the problem easier because you might be able to see where some information goes a little bit better if you can see what the picture actually looks like. So let's go ahead and read the problem and figure out if we have any information we can now plug in our diagram. So they tell me I have a kite string that's 200 feet long. So that's going to end up being the hypotenuse of this right triangle, and actually I'm going to label that hypotenuse at this point. And I can see that that's definitely where the 200 goes because look, that's the actual kite string. The angle of elevation, as we talked about in class, is always the angle along the ground. So down here, down here is going to be where my 58 degrees goes. So that's the angle of elevation. You may want to circle that angle because that's going to tell us what the other sides are called based on the angle we're looking at. And then the question they asked me to figure out was how high is the kite, which is this vertical side. I'm going to use x. I don't want to use h for height, only because that might confuse me with hypotenuse, and I don't want to deal with that. So I'm going to say that that's just going to be x. Well, I need to go ahead and figure out what the other two sides are called. So we've got the hypotenuse figured out. Based on this, the angle that I'm looking at, this side over here must be the opposite side. It's the side that's across from the angle I'm looking at, which leaves the bottom side to be the adjacent side, although as you can see there's no numbers, there's no question about that side, so I'm just going to kind of ignore it. Which means I'm working with hypotenuse and I'm working with opposite as the two sides. Looking back at SOHCAHTOA, I can see which part of SOHCAHTOA uses opposite and uses hypotenuse, and from memory or from my notes, I can see that that must be the SO part of SOHCAHTOA that I'll be using this time because it's got opposite and it's got hypotenuse in it. The S in SOHCAHTOA stands for sine, telling me that that's the trig function I'm going to use to solve this problem. So let's go ahead and write our equation and then solve from there. So I'm choosing to use sine because I'm working with opposite and hypotenuse, and it's always sine of the angle, so sine of 58. I'm going to put that over 1, and then equals, the opposite side is x in this case, and the hypotenuse is 200. So go ahead and get your calculators out, or if you're using a trig table, look up the sine of 58. Typically 4 decimal places is a good number to round to when you're working with these problems, so I went ahead and did that on my calculator, and I found the sine of 58 to be about 0.8480. And then over 1, I like to do these as proportion problems, and then equals x over 20. If I finish solving this, I'll cross multiply. 1 times x is just x. When I cross multiply the other way, 200 times 0.8480, I end up with, I'll round that to the nearest whole number, so oops, I guess I should do approximately. I end up with an approximate answer rounded to a whole number of 170. Remember, we were finding the height of a kite, so I'm going to use a label with that. That kite must be 170 feet in the air.